But we didn't really know what that meant. No real solutions. Now we do, because in section 4.8 we learned about our imaginary number I. So even though a quadratic formula could have no real solutions, it can have two imaginary solutions. And that's what we're going to be dealing with here today. So we've got our quadratic, x squared plus 3x plus 12 equals 0. Let's solve it using the quadratic formula. This is a good review because the quadratic formula is something that's not going to go away. First, you want to define a, b, and c. A is the number in front of x squared. B is the number in front of x. C is the constant. Now plug it in. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, if you want, you can grab yourselves a calculator and you can simplify with a calculator, or you can just simplify by hand. We're going to have negative 3 plus or minus the square root of 9 minus 48 over 2. X equals negative 3 plus or minus 9 minus 48. That's the big difference here, because we get a negative number. We get negative 39 over 2. None of your problems that we did to this point had a negative under the radical. Or let me rephrase that. None of them should have had a negative under the radical, as long as you simplified correctly. Because up until this point, we didn't know what to do if we had a negative square root. But now we do. How could we take out that negative from the square root? Killian?
That little I thingy.
Yeah, that little I thingy. We can simplify this using I. All we need to do is say x equals negative 3 plus or minus I root 39 over 2. Think about the very first problems that we did in 4.8. We were simplifying with I. We were taking a radical like this right here and simplifying it simply by taking out I. That's all we're doing with this problem. How many answers are there?
2.
That's right. There are 2 answers there because of the plus and minus sign. 2 imaginary answers. Let's try another. X squared minus x plus 1. Someone give me A, B, and C. Lindsay.
A equals positive 1, B equals negative 1, and C equals positive 1.
Good. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Simplify. X equals 1 plus or minus root negative 3 over 2. One more step to simplify. X equals 1 plus or minus I root 3 over 2. Our next problem is not in standard form. What do we need to do for this problem before we use the quadratic formula? Caleb?
You need to put the -4 on the left.
Yeah. Four x squared plus 7x plus 4 equals 0. You need to be in standard form before using the quadratic formula. A is 4, B is 7, C is 4. Could somebody fill in the numbers for me? X equals, Paul?
X equals -7 plus or minus the square root of 7 squared minus 4 times 4 times 4
Yep.
over 2 times 4.
Good. So we've got x equals -7 plus or minus the square root of -15 over 8. So what would that be in its simplest form? What should my final answer be, Megan?
-7 plus or minus I root 15 over 8.
Good. So we're just putting together two of the things that we've already done. We've already done the quadratic formula. We've already simplified with I. Now we're just putting it all into one problem. Let's do one more example together. Now for number 4, it's already in standard form. So we have A is 2, B is -6, and C is 8. X equals -b plus or minus square root b squared minus 4ac all over 2a. (36 minus 64 all over 4). So we have x equals 6 plus or minus the square root of -28 over 4. Now from there, how would I simplify that? Think about what we've been doing in all of our problems. Lindsay?
We make it x equals 6 plus or minus I, and then make negative 28 positive and put it all over 4.
Very good. I have a surprise for you. We're not quite done. Okay? For all of the other problems, this is as far as we went. But what do you notice here? There's something special about this, Caleb.
Everything's divisible by 2.
That's true.
You can divide.
Well, that's true. Everything's divisible by 2, but remember, we're not allowed to divide the radicand. We're not allowed to divide something if it's under the square root. Megan?
28 has a perfect square.
Bingo. Perfect squares need to be simplified. The square root of 28 has a perfect square. It's what? 7 and 4. The square root of 4, the square root of 7. This becomes 2 root 7. Anytime you can simplify a radical, you should. So now we have x equals 6 plus or minus 2I root 7 over 4. Because we've simplified the square root of 28. The square root of 28 became 2 root 7. Now we can use Caleb's idea of, hey, these are all divisible by 2. Because 6, 2, and 4 are all divisible by 2, leaving us with a final simplified answer of 3 plus or minus I root 7 over 2. Paul? We didn't divide anything inside the square root. We divided the 2 outside of the square root.
But it's still under it, isn't it?
No, the only thing under the square root is that 7. That's why we simplified. All right, so this problem is definitely the problem plus some. This is the problem amplified. The problem on steroids, if you will. Okay, because not only did we have to simplify our radical, we also had to simplify the fraction. So this is pretty much the most complex that you're going to get whenever you're doing these quadratic problems.